Hello everyone, welcome back to the channel. So in this video we will be talking about edge computing and the uses of edge computing, and also how edge is different from cloud computing or difference between them, and some of the use cases and future trends on edge computing. So this is the content for the video. Now let's jump into it. So first, let me introduce you to edge computing. So what is edge computing? So basically, edge computing is a distributed computing model that processes data closer to the source. What does it mean? First, let's understand with the distributed computing model. So what is a distributed computing model? So basically, in distributed computing model, multiple machines work on the same task. You get it? Multiple machines works on the same task. That is called distributed computing model. Or what it does is that it processes data closer to the source. So what does it mean that processing data closer to the source? So basically, first let's understand what is source. So basically, source is from where data is generated. So here are some example like IoT devices, sensor, or local servers. So from where the data is generated. So what it does is that it processes data on the local service instead of relying on the centralized server, that is a cloud based centralized server. So what this does is that it reduces the latency. So now another new word, latency. What does it mean? So basically latency means sending the request and getting the response. So the time is basically a latency, you can say. uh, the more time it will get, the higher the latency will be. We can define it by saying that delay in data transmission is called latency. So basically, if there is high latency, that it means that there is delay or buffer in data transmission. The another thing is that it also reduces bandwidth usage. So what is bandwidth? So basically, bandwidth is transferring data to the server. So like if we are transmitting data in a very high amount, then the bandwidth will be high. So in edge, what we do is that we will send only the essential data or to the cloud. Or suppose we want to do some complex computation on the data that we cannot do on the edge, then we will send the data to the cloud. So the bandwidth of the edge is very low, or you can say centralized server, the bandwidth of the edge is very low. And also response time, bandwidth and also response time is low. As we know this, it have low latency, then of course it is obvious that it will have low response time. And of course it does make it ideal for real time application, because in real time application we required instant response from the servers. So this is I think this is introduction to the edge, how edge works. And now there's a term called decentralized processing. What is decentralized processing? So basically, two types of processing are here. The first one is centralized processing. So in centralized processing, there is one central server where data is being processed. So if we want to do something, we have to directly send the request to the cloud or the centralized server. And in decentralized network, what happen is there are multiple small servers, or we can say small edge, where we can process data. It can be on the device or on the local servers. So I think this is what decentralized means and centralized means. Now here are some points. That's data generation. So of course data is generated by edge devices like IoT sensors, or something like that. And edge processing, as we understand that what edge processing means, processing data on the edge. And real time action, of course, because of low latency, the response is faster as compared to cloud computing. So this is how it works. Now go to the next slide. So how cloud, we're going to go to difference between cloud and edge. We're going to talk about the difference between cloud and edge. So here are some point on basis of latency and bandwidth. So first, high latency. So cloud have high latency because data, we have to send data for even small analysis to the cloud, and then we will get the response. So of course it will going to have high latency. The data transmission will take time. And here the edge will have low latency because the data is processed near the data source, so we don't have to do like something like send the data to the central server, and then it will process, and then it will give again us the response. So for that, it have low latency. Now high bandwidth uses, so require significant bandwidth. Of course cloud will going to require the significant bandwidth, because he have to send because it send the data to the centralized server for processing a bunch of or a bulk of data. Of course it will going to increase high the bandwidth and low bandwidth uses. So in cloud, in edge, what happen is that the data is processed on the edge, and only the complex tasks that cannot be performed on edge, then the data of that will be sent to the cloud for analysis or for store. So of course it will only the so of course what is say that only relevant data is transmitted. So of course it will going to it have a low bandwidth. And centralized data processing, of course the data is processed on the central servers, and here distributed data processing, of course the data is processed on the edge, nearest edge, and limited real time suitability. So the cloud the cloud have a suitability with real time processing, we can say, but in some critical points, or we can say critical time, we cannot use cloud here in cloud. And it is of course ideal for, because we can get instant response, and in the some instance processing we cannot use the cloud for that, because a millisecond can cause chaos. Now edge what are the benefits of edge for real time apps? We're going to talk about the benefits of edge for real time apps. So edge computing enhance various applications, of course. First is that it reduces latency. So what it does is that it reduces the latency, the response time, of course the response time. In like in some situations where we have to have we have to have the response in faster. Suppose some obstacle comes and in front of your car, so in that cases if we suppose the car or the machine have to respond instantly. So for that cases millisecond can be can cause a problem. So for that it is very helpful, the edge, of course it is so that the machine can act accordingly. Now enhanced reliability, what does it mean? So suppose on medical devices, the great example of that is medical devices, where reliability is a major issue. So on that case, suppose something is happening, and you want to suppose a patient wearing some wearables, and he got something like a heart attack or something like that, and there is a network issue, and the wearables can send the alert or warning to the emergency, so that can cause problems. So for that we are using edge. So without without network, or even in low networks, it can work fine. So this is how enhanced. Now improve security. So how it is improving security? So in the centralized servers, what we are doing is that we are sending data to the central server. So in the process of sending to the data, there the data can be lost, or the data can be tapped, or this thing can happen. So basically if data is processed locally, then there are less chances of the security. Now cost saving. So of course it is cost saving, because it reduces bandwidth, the need to send data to the centralized server. So of course it will going to reduce the cost. Now here are some of the challenges for edge computing. We are going to talk about the challenges while implementing edge computing. So first is infrastructure complexity. So what does it mean? So basically infrastructure complexity means like setting up the edge environment. So first we have to get the servers for that, local servers for that, and also the sensors, and we are going to have like experts for implementing that. So of course there are complexity and security concerns. As we previously talked about, we said that if we are sending data, then there is a security and it is secure, but it is not that case. So in what happen is that the data is processed locally, so it does not have security as strong as compared to cloud centralized server for storing data. So in those cases there can be physical harm or something like that can happen, and someone can have the data. So this is the point. And the limited and another one is limited resources. So of course edge devices have constant, we cannot have this much powerful machines at each edge. So sometimes the data processing cannot be done on a edge, then and though in those cases we have to send the data to the centralized server for processing, but it can be managed. And initial investments, of course initial investment is high in edge computing because we have to set up servers, and as I previously mentioned, and of course it requires expert, and expert of course require experts. Now let's understand edge with an example, or you can say use case of autonomous vehicles, how edge works in autonomous vehicles. So first let's understand real-time data processing. So why like how real-time data processing is used in autonomous is that for navigation and obstacle avoidance. So basically it is real-time data processing, that like the camera is monitoring the road or the GPS and something like that, and in those cases it is continuously monitoring, and something if something comes in front of a car, then it will have to act accordingly, or we can say have to analyze that. So for that real time data processing is very crucial in that case, of course for navigation and obstacle avoidance as I mentioned, and low latency responses. So basically this is one of the like most important, that is it ensures safety critical functions. So there are as we mentioned, that obstacle, it can be big, it can be high, it can be harmful for us, or we can say something like that. So in that cases it ensures safety like through fast response. So if we get fast response, it will hit the brake if something is coming in front of that. So of course in that cases the low latency is helpful. So onboard processing, what does onboard processing means? So basically onboard processing means having AI chips inside the car, or on the edge we have AI chips or something like that, that will run the algorithm on the edge or on the in the car itself. Some of the car like most of the cars of Tesla uses it. Basically it have AI algorithms running on the edge, so it will act according to that, of course. And yeah, as we shared, Tesla uses edge computing for object detection autonomous vehicle. And here is the fact that autonomous vehicle generate up to 4 terabyte of data per day. So in that case sending all the data to the cloud, uh, I don't think so. Now in industrial automation, how in industrial automation works. So first is that real time monitoring, we will monitor all the machines, if monitor machines using camera and sensor, something like that, temperature sensor, vibration, and that. And the second point is that predictive maintenance. What predictive maintenance is, that we will predict the failure of the machine before, like we will predict if something is going to happen using by running AI algorithms or and machine learning algorithms, and then we will predict the maintenance. And then of course faster response, if something is happening, faster response is very much of a helpful. And of course it will decrease the downtime if we predict the maintenance before and work accordingly or act accordingly, then it will of course decrease the maintenance. Now there is another use case, that is in the field of healthcare. So of course edge play a vital role in the field of healthcare. So now here are some points, like remote patient monitoring and timely alerts. What does it mean, remote patient? So here are we have some wearable devices which tracks the heart rate and blood pressure and many things, and if something happens then it will send the alert to the emergency or the hospital nearest in case of emergency. So suppose someone is having a heart attack, then it will send the alert to the doctor or to the nearest emergency, or we can say ambulance, like that. So it is like very helpful. Suppose in that case as I previously mentioned, that if there is a network issue, then it will took something someone's life, or can be more of a year like that. And real time image processing, of course it is helpful in real time image processing, and faster and reliable service. It is faster, so that sometimes a millisecond can do the job. So of course it is faster and reliable, so it will get the faster, we will get the send the alert fast and then act accordingly. Like a smart device analyzes patient data and provide recommendation, and of course it analyzes previous data on the local and give recommendation to the patient. Now here are some future trends in edge computing that is evolving rapidly. So 5G integration, of course, 5G will increase the edge, faster connectivity for devices. Of course, it will going to provide us or by 5G it will also decrease latency, and of course it will going to be like that. AI at the edge, it is one of the major trends. Like AI at the edge, AI is like running AI algorithms on the edge machine itself. So here we are running the models on edge, here running the AI AI models on edge, and then uh, we will get the faster response from the more faster response from the algorithm, or we can say we are processing or analyzing the data on the device itself. So it is very helpful in autonomous vehicles, in the field of healthcare, in the field of automation, in the field of smart city. It is very much of helpful. What is serverless edge? Deploying application without managing servers. So of course, as the word mentions, serverless edge. So we can use multiple small servers, and that is it. So here is the conclusion: the power of edge. So edge computing will make technology smarter, faster, and more efficient in smart cities, healthcare. Of course, how edge is it mentioned how edge is working in the field or like faster and more efficient in smart cities, in the field of smart cities and healthcare, in the field of industrialization, and retail, gaming, and farming. So it is very much of helpful in each and every field. With a 5G, AI, and IoT devices, edge computing will power the future of real-time application. Of course, it is the fact that edge is the future of real-time application. So, so this is it for the video. If you do like the video, and if you learn something from the video, make sure to subscribe to the channel and like the video. And thanks for watching the video. Bye bye.